Welcome to Care Coordination and Interoperable Health IT Systems, Implementing Health Interoperability, Lecture D. This unit will cover the following learning objectives. Number 1. Identify major tasks required to implement interoperability. Number 2. Explain why interoperability implementation projects are needed. Number 3. Define and discuss each phase of the interoperability implementation lifecycle. Number 4. Describe how to apply each phase of the interoperability implementation lifecycle to simple interoperability implementation problems. And number 5. List types of production issues with interoperability and identify and describe support strategies. In this lecture, you will be able to identify and describe the quote, build unquote phases and quote, test unquote phases of healthcare interoperability projects. You will be able to describe how to apply the build and test phase of the interoperability implementation lifecycle to simple interoperability implementation problems. The build phase of the implementation project is when the design is executed. The work might include changes to the sending interface, changes to the receiving interface, translations and filters added to the interface engine, changes to user interfaces, changes to terminology mappings, integration into the EMPI, changes to user workflow, changes to other affected systems, and user training and documentation. Ideally, all the necessary changes are already specified in the design documentation that provides instructions for the builders. We are using the term, quote, builder, unquote, to represent anyone who is doing the actual work of implementing interoperability. For example, technical changes are often done by programmers, while workflow changes are often facilitated by business analysts. This is a time when parallel work is done, so project management control is important. It is not uncommon for additional requirements or design flaws to be uncovered. The build phase is complete when each builder has completed their components. This means that each has been tested and each builder believes they have a working component. If possible, messages and documents have been validated using validation tools. Finally, the phase is completed when their code or configuration has been reviewed and approved. When the build phase is complete, you can move into the testing phase. The testing phase of a project is when interoperability is tested from end to end, following a formal list of scenarios. Problems are detected and resolved, and then testing is repeated. These steps repeat until testing is fully successful. It is important to prepare for the testing process. The steps to prepare for testing include writing a test plan, establishing who will test, providing training for testers, setting up the testing environment, and scheduling the actual test. Remember that the test will need to be repeated numerous times. One of the most important steps in testing is to plan the test. The test plan development work can begin as soon as the design is done. The design document is a helpful basis for the test plan. Sometimes creating the test plan will actually uncover flaws before any testing has occurred. The goal of the test plan is to fully test that requirements are met as designed. Sometimes people are tempted to do unplanned experimentation with the system and call that testing. That technique is useful, but is not a replacement for a thorough planned test process. There are methods to writing good test plans. This slide shows many useful tips to create a good test plan. First, do not start from scratch. Find a prior test plan whenever possible. As noted before, use the design document to guide the test scenario development. Make sure to test all possibilities. Test a specific scenario. Variations should be new scenarios. Specify input or include place for tester to specify. Sometimes, testers like to reuse the same records used in prior tests and keep updating them. However, these records might be corrupted by failed tests. Ideally, you should start with new test patients and new test data. Design tests as pass or fail, so it is easy to determine if the test was successful. A good test plan is not just a list of tests. It is actually a template for the tester to record test results. Include a place to indicate pass or fail, and provide a place for the tester to document failure details. Instruct the tester to print or save screens on the systems involved. Also, include a place for tester to sign. This slide shows an example test plan section for testing the transmission of a care summary to support a referral from a primary care provider to a specialist. Notice that it consists of a series of specific scenarios with pass-fail questions and a place to indicate the result of the test. The National Institute of Standards and Technology, or NIST, publishes test plans for vendors who are certifying their systems for O&C. These test plans and accompanying test data are nice examples of test plans. NIST also provides several testing tools, which can be used for interoperability validation. One of the biggest challenges of testing interoperability implementations is identifying the resources to do the testing. First of all, testing for interoperability implementations requires a knowledge of multiple systems. Most people are specialists in one system. Testing is resource-intensive and requires skill. A good tester is analytical, likes to break things, and is also patient since testing is time-consuming and repetitive. When selecting testing resources, do not select people that did the building because they already think their stuff works. Users are often asked to test, but often they do not understand the systems in enough depth and are not able to dedicate the time and are not analytical enough. You could have a team of testers involving one expert from each system, but the coordination challenges can lead to inefficiencies. The best testing resources are analysts who specialize in testing, and they are called quality analysts. The state of the test environments matter. The environment needs to match what you anticipate production will look like after go live. Do not forget to test interface connections and to test systems to interface with your system. All table values should be loaded, so if a patient is admitted to Nursing Unit 5 South in the Patient Management Test System, but 5 South is not configured on the EHR test system, the admission message will fail when received by the EHR test system. Occasionally, a test system might not be available. This should be avoided as much as possible. However, if this occurs, sometimes the vendor will allow you to borrow a test system or test instance in the cloud. Sometimes test patients in production can be used, although this is dangerous because you do not want to corrupt production and want to limit production use for HIPAA reasons. Also, many tests require multiple patients. Sometimes you might have to schedule downtime of a production system to allow for testing. This is a last resort. Testers most likely will need some training or orientation. You will need to make sure they are able to use all systems they will need to access, that they understand the test plan, and that they understand how to document the test results. Also, they need to know who to contact if they have problems carrying out the test. Sometimes the test plan writers are also the testers. Interoperability testing requires a working environment with multiple systems involved. Make sure that the test environment is working, that the testers can access all the systems involved, and that everyone is available who is needed to run or support the test before you start. Remember that testing is a repetitive process in which scenarios are tested, failures are determined, fixes are made, and testing is repeated until you have a working implementation. Make sure to allocate enough time for the full process. Testing is a tedious process, so allow the testers to do their work efficiently by providing a stable test environment and immediate support when needed. Also, testing is more efficient when you do not stop to fix every problem found. Fix showstoppers quickly and not during the tester's time. Fix a batch of problems at once prior to rerunning the test plan. If the interoperability fails in production, who will be blamed? A thorough and successful test is your best assurance against failure. Make sure testing happens right by ensuring that test plan writing starts early, suggesting test scenarios, reviewing the test plan, making sure the testing process runs smoothly, and making sure that a full retest is run after the last fix. This concludes Lecture D of Implementing Health Interoperability. To summarize, the build phase is when the actual work is carried out, as identified during the design phase. Since many things are occurring at once, project management is important. When the code or configuration is reviewed and approved, the build phase moves into the test phase. The test phase is when interoperability is tested from end to end, following a formal list of scenarios, and is a repetitive process. Therefore, it is important to allocate enough time and to be thorough with preparation.